Hello everyone, and welcome back to the Nucleic Acids channel, your go-to destination for these building blocks of life. I'm your host, Ayesha. Let's dive into today's challenge. We need to find the location and interactions of this protein with its gene sequence. I've got just the technique. Chromatin immunoprecipitation. Chromatin immunoprecipitation uses antibodies to examine how a specific protein interacts with DNA and the location it binds on the gene sequence. CHIP was discovered by John T. List and David Gilmore while analyzing the E. coli and Drosophila genes and their transcription by RNA polymerase II. The CHIP technique is an in vivo process, meaning that the procedure is performed in a living organism. This shows the live interactions between the proteins and their binding sites on the chromatin. Chromatin consists of DNA positively coiled around a histone core, forming nucleosomes. Multiple nucleosomes together create chromatin. The first step is cross-linking DNA and proteins using the common agent formaldehyde. Formaldehyde enters the cells through the cell membrane and binds the proteins to their binding sites on chromatin. After fixing the proteins, chromatin is fragmented using either restriction enzymes or sonication. Restriction enzymes like amylase cleave the double-stranded DNA, while sonication uses the vibrations from sound waves to break it into smaller pieces. Next, immunoprecipitation uses an antibody to isolate the target protein's DNA from the mix of fragments. The designed antibody binds to the protein DNA complex on the chromatin fragments. After attaching the antibody to the protein DNA complex, the crosslinks from step 1 are reversed by heating the samples at high temperatures and high salt concentrations. This causes the formaldehyde crosslinks to break, releasing the chromatin fragments. Some variations may use magnetic beads to pull apart the antibody protein DNA complex from the chromatin, isolating the desired DNA fragments. Following immunoprecipitation, the target DNA fragments are purified. This is achieved through methods like washing with phenylchloroform, ethanol precipitation, or column chromatography. Finally, the DNA fragments can be separated and analyzed through PCR, real-time PCR, or microarray techniques. Recent advancements have greatly improved our understanding of chromatin immunoprecipitation. Incorporating different analytical techniques with CHIP allows high-resolution, genome-wide exploration of protein DNA interactions. In particular, CHIP sequencing has revolutionized bacterial nucleoid research.
Created using Powtoon.